Okay, so in this video we're going to be reviewing all the different, I consider them miscellaneous operations you can do on matrices in MATLAB. Okay, and so MATLAB is a very powerful software, and so it's used in a lot of universities and professional as well. One of its main strengths is that it makes it very easy to work with matrices. Okay, and so it makes defining matrices very easy, and it makes performing operations on matrices very easily. And so what you'll see is that the more and more you use MATLAB, you start to think about your problems in terms of matrices, right? And so if you have a mathematical problem, if you can put it in some kind of matrix form, then it makes it very easy to apply and solve in MATLAB, right? And so as an example here, we have a system of linear equations, three unknowns. If you put this in matrix form, where you extract out the coefficients and extract out the right-hand side, this is something that MATLAB is very well equipped to do, and you can solve this equation in literally probably like 3 lines of code. Okay? And so there's tons and tons of different things that you can do on matrices. And so if you've taken a linear algebra class, you know. And so luckily, MATLAB has a function for most operations that you can perform. And so I think the first operation we'll go over here is a matrix transpose. And so a transpose is simply just a swapping. And so if you have a matrix defined in terms of rows and columns, if you kind of rotate that matrix, in other words, you write the rows as the columns, right? And so you see here we have 1, 2, 3 in the first row. When we take the transpose, that 1, 2, 3 first row now becomes the 1, 2, 3 first column. Okay, same thing with 4, 5, 6. And that's the transpose. And so the quick way to perform transposes in MATLAB is to use this apostrophe operator. Okay, and so if you have a matrix, you just use the apostrophe operator, and then it automatically is going to return the transpose. So because transposes are quite common in linear algebra, MATLAB has a very quick way to do it, and so that's what the apostrophe does. And so if you see apostrophe in a MATLAB code, all it means is just a matrix transpose. Okay. Another common operation that you'll see is a matrix inverse, and so the inverse of a matrix is another matrix, where if you multiply that by the original matrix, what you get is the identity matrix. Okay, and so if you recall, the identity matrix has ones on the diagonal and zeros everywhere else. Okay, and so the way that you compute the inverse is that you use this INV function. And so if you have a matrix A, you want to compute its inverse, you do INV, and then in the parentheses you put that matrix where you want to compute that inverse. Okay, and then here I'm testing it out just to show you, and so I'm doing a product test 2, and so I'm multiplying A by its inverse, and what you see is that we get the identity matrix in both cases. And so we see we have ones on the diagonal. These numbers look like they're very big here, but if you notice the exponent, they're 10 to the minus 16, which is very, very small. So that's 16 places after the decimal. And so these are essentially 0. And so the thing with programming is that normally it's very hard to get exact stuff because computers have finite precision, but this is effectively 0. It just doesn't look. It just looks kind of scary, but it's 0 basically. Okay. All right, so another common operation you can do is a determinant. And so you can take a determinant of a square matrix, and what you get is a scalar value. And it's hard to really define what the determinant is used for in one sentence, because it's used for a lot of different things. But you've probably come across the determinant in some of your previous classes before. And so I know it's used in it's used to assess how fit the matrix is, how well it can be inverted. It's used in solving linear equations. It's used in volumetric scaling. It's used for a lot of things. And so MATLAB has a function for it. And so to find the determinant of a matrix, you just use this command here called det, or det, and then you use it the same way as the inverse. You use det, and then in the parentheses you put the matrix A, and then you compute its determinant. And so here's the determinant of this matrix here, which is minus 427. Okay, and so a bit more of an advanced feature is you can find the eigenvalues and eigenvectors of a matrix as well. Okay, so this is probably something that you probably learned in your linear algebra class and promptly forgot it. And so, but MATLAB has a quick way to do that. And so the function for that is to use this eig command, right? And what's unique about this eig command is that it actually returns 2 values. And so, you often want both the eigenvectors and the eigenvalues, and so you can, return both of them just like that. And so, for a lot of times you're probably not going to use this, but it's useful to know that it does exist if you take some advanced mathematics courses. Okay, and we only have just a short time in this video, but that's just barely scratching the surface on what MATLAB can do. So, what I always tell people is that if it was taught in some linear algebra class somewhere on planet Earth, there's a function for it in MATLAB, right? And so, in these cases, if you have some kind of niche application that you want to do on a matrix, MATLAB probably has something for it. And so, in those cases, Google is kind of your best friend. And so, some applications that I've used is like an LU decomposition, singular value decomposition, SVD. You can do matrix convolution, and you can find the characteristic polynomial as well. Okay, if those don't mean anything to you, don't worry about it. Those are fairly kind of advanced stuff, but just know that MATLAB has your back for anything you really want to do with matrices.